Okay, so now we're starting to move into the third phase of this course, and I want to help you to become master at deductive reasoning. This is called classical deductive reasoning, okay? Now, deductive reasoning has this classical part, which goes in the book is chapters 5, 6, and 7. And then in chapter 8, it goes into symbolic logic. That's also deductive reasoning. So deductive reasoning has like two categories. One is called classical deductive reasoning. The other one is symbolic deductive reasoning. So we're going to really focus on classical deductive reasoning, and we're going to just take our first steps into symbolic deductive reasoning. And my colleague, Professor Beach, teaches a whole course using the same book, so you wouldn't have to buy another book. And he does the symbolic logic in depth. So I really recommend you doing both courses if that's possible. So we're going to really focus on deductive reasoning, classical deductive reasoning. And the first step is to understand categorical propositions. So I'm going to ask you to study 5.1, chapter 5.1, 5.2, 5.3, 5.4. 5.5 is the traditional square of opposition and further immediate inferences after that. Now I'm postponing that and coming back to that later when we move into phase 2 of this, or the second big part of this course, part 2, where we're talking about inventive reasoning, inventing arguments, because the square of opposition is basically a way of inventing new inferences. So in chapter 5, I'm just going to ask you to do chapter 5.1, 5.2, 5.3, and 5.4. I'm using the 14th edition. My 15th edition hasn't come yet, so the sections may not be the same, but basically 5.1 is called the theory of deduction. It's probably the same in the 15th edition. 5.2 is classes and categorical propositions. 5.3 is 4 kinds of categorical propositions. And 5.4 is quality, quantity, and distribution. So that's what I want to talk about. I think the numbers are probably the same in the 15th edition, but if not, those are the topics. Theory of deduction, that's the first section of chapter 5. Classes and categorical propositions, 5.2. The 4 kinds of categorical propositions, that's 5.3. And quality, quantity, and distribution. And then chapter 5 also goes into what's called the traditional square of opposition and further immediate inferences, namely conversion, obversion, and contraposition. But we're going to come back to that. I'm introducing this material in a particular way because I've realized as a teacher for so long, and even as a dog trainer, it really matters how you learn something. And sometimes when I'm practicing music, I spend a lot of time trying to find out the best way to learn a particular kind of musical theory and so on. So the way you learn something is very important. So I put a lot of thought into how I'm introducing this material to you. And I'd like you to do it, to learn it in the way that I'm proposing. If you listen to my lectures, basically are just to help you understand the text. But in the second part of this course, I'm dividing the course into 2 big parts. So part 1 is critical thinking, and that's making judgments about other people's arguments. With deductive reasoning, the judgment is it valid or is it invalid? With inductive reasoning, is it highly probable or not so probable? If it's highly probable, that means the conclusion follows with a high degree of probability from the premises. then it's a strong argument. But you can't really say it's valid. Validity, as we studied in part 1 of the course, validity has to do with deductive reasoning. So I'm introducing this material in a very particular way, and if you learn it this way, it's going to help. Now, like any structure, the foundation is like the main thing. If the foundation is shaky, then everything falls apart. So it's really important to master the foundation. If later on you make a mistake, you can fix it. But if the foundation is not strong, it all falls apart. So you won't be able to. So for example, if you don't master this material here, then as you move forward, there'll be all kinds of problems that you'll have to undo. And it's really hard to learn something that way. So foundation is everything, okay? If you make a mistake later on, you can fix that, but fixing the foundation is much more. So make sure you master this material. So what I want to talk about today is categorical propositions. So you know by now that an argument is made up of premises, which are the support for a conclusion. And both the premises and the conclusion are propositions. Now in classical deductive logic, if the conclusion follows with absolute necessity from the premises, then that argument is called valid. Okay, so only deductive reasoning, only deductive arguments are valid or invalid. So that's the judgment when we talk about critical thinking. When you're making a judgment about someone's argument, the first thing to do is to find out if it's valid or invalid. And then if it's valid, then the next thing is it sound? Remember the difference between validity and soundness. Soundness means the premises are true, the conclusion's true, and the conclusion follows with absolute necessity from the premises. Then it's sound. It's like the best thing you can say about an argument. And when you construct arguments in part 2 of our course, you're going to try to strive for soundness. You want to make sound arguments. So remember now that deductive arguments are ones that provide conclusive grounds for the truth of the conclusion. Now, another way of saying this, remember, there's a big difference between validity and truth. Truth has to do whether or not a proposition corresponds to reality. There's a lot more to say about the essence of truth, but for now, it's important just to realize a correct thing to say about truth. Only propositions are true or false, and propositions are true when they correspond to reality. Now, of course, that raises the whole question about reality and so on. It raises bigger questions. But for now, this keeps things clean and clear. If you want to go deeper into that, then that discipline is called epistemology, the study of knowledge. And then deeper than that even is called ontology, the theory of being, and metaphysics, the study of reality. But we don't need to go that deep for now. All you need to know right now is that only propositions are true or false. So arguments are not true or false. Propositions are true or false. So like if I say all lawyers are all politicians are liars. Well, that's false because not every politician is a liar. If I say some politicians are liars, then that's true because some politicians are liars. If I say no politician is a liar, then that's false because some politicians are probably liars. So the question about truth is an empirical issue. And in order to become good at that, you have to educate yourself. Over time, you educate yourself. As time goes by, you realize some politicians do lie. Some politicians don't lie. And it's not true that all politicians are liars, but some politicians are liars. And it's not true that no politician is a liar. So this just becomes a part of your common sense from observing life. Also, to go deeper than that, it's from your general education. So the more you study and more you educate yourself, the better you are at discerning the truth or falsity of propositions. But that's not the task of logicians. Logic is not about whether or not propositions are true or false. Logic is about the reasoning process, okay? But that's not to say that whether or not a proposition is true or false is not important. That's very important. It's just not part of the purview of logic. It's not what logicians do. It's not part of critical, it's part of critical thinking, but it's not the process of making judgments about the validity or invalidity of deductive reasoning. So the essence of deductive reasoning, of classical deductive reasoning, is called the syllogism. And we're going to really study that carefully. It's just one word, syllogism, but there's a lot that goes into that. So we're going to unpack that. And it's going to take 3 chapters to do that. Okay, so the first thing you need to realize about, so this talk is just about categorical propositions. And these are the building blocks of arguments, of deductive arguments, okay? So why is it called categorical propositions? Well, because this proposition is about categories or classes. So a class of things or a category is something that all these beings have in common. So like if I say politicians, then that's what all these human beings, men and women, have in common. They all have in common this profession of being a politician. So politician is a category or a class. But what if I say liars? Well, what is a lie? A lie is when you know the truth and you say something else. So whenever that category of being a liar, of liars, is all those groups of people who say one thing and know that it's not the truth and say it anyhow. That's called a liar. Okay. So these are 2 categories, politicians and liars. Now, categorical propositions always have a subject and a predicate term. Like if I say the tree is tall, the word tree is the subject of that sentence, of that proposition. And tall is the predicate. The predicate is the quality that pertains to that subject. If I say all politicians are liars, I don't think that's a true statement, but let's just say sometimes logicians just use, you'll see when Copy gives examples or any logician gives examples, they're indiscriminate about the truth or falsity of the propositions because they're trying to emphasize the reasoning process. Like I said, whether or not a proposition is true or false is an empirical matter. That is, it's based on your common sense and your knowledge, your education, and your observation of life. But whether or not the reasoning process is valid or invalid is the task of the logician. That's critical thinking. Critical thinking also involves truth or falsity, but the big part of logic, the logic part of critical thinking has to do with the reasoning process. Let's just remember the definition of logic. Logic is the study of the principles and methods used to distinguish correct from incorrect reasoning. So the logician, as a logician, is not concerned about the truth or falsity of propositions, but only about the reasoning process. So you need to know about categorical propositions, and I'm trying to help you understand it. But Copy is very clear about it. So if you do the reading and do 3 or 4 examples from the exercises, and you listen to these lectures, you should be all right. So these propositions then have a subject and a predicate. Okay. Now the subject and predicate, and I keep going back to that one example just to keep things simple. Remember I told you sometimes if you memorize one example, then you could just go to that example to understand the theory. And so let's go back to all politicians are liars. I don't think that's a true statement, but let's just say. So what is that So what is the subject of that sentence, that proposition? Politicians. And what is the predicate? Remember, the predicate is some attribute of that subject. That's liars. Now, this subject and predicate can be completely included in one another, or they can be completely excluded from one another, or they can be partially included in one another. So Copy explains all that quite nicely. And logicians have agreed upon four kinds of propositions, okay? And that's based on qualifiers and quantifiers. Now in deductive logic, there's only two quantities. There's universal, that means everything in a class. Like all politicians are liars. Again, that's not a true statement. If you tell one lie, that doesn't mean you're a liar. You know, a liar is somebody who does that habitually. Okay, so that's not a true proposition, but it's a proposition. All politicians are liars. So I'm talking about all the politicians. So that's called universal. If I say some politicians are liars, that's probably a true statement, given my observation and my common sense. Then actually, it's an empirical matter. If you have somebody talking incessantly and they check the facts and everything that he or she says is a lie, then you can conclude the person's probably a liar. But like I said, we're not dealing with the true or falsity of propositions. I'm just trying to explain what a categorical proposition is for you. So if I say some politicians are liars, then I'm not talking about all the politicians, only some. So there's only two quantities in a proposition, all or some. Now there's also two quantity. Did I say quantity? I meant to say quantities. There's only two quantities, all or some. Remember, quantity is how much of something. So there's only two quantities. There's all or some, okay? And there's only two qualities. There's affirmative or negative. It's not a negative and positive. Don't use those words. Use affirmative and negative. So you have two qualities and two quantities. The quantities are universal and particular, and the qualities are affirmative and negative. So 2 times 2 is 4. So that means there's 4 kinds of categorical propositions. And if you use S and P to symbolize subject and predicate, then you have all S is P. Now, what is the quantity of that one? It's universal. And is it negative or is it affirmative? Well, it's affirmative. You're not negating anything. If I say all S is P, it's universal because I'm saying all, and it's affirmative. I'm not negating anything. So I can instantiate. Now Copy doesn't use that word enough. It's an important word for us though, because we're going to instantiate arguments later. Instantiation is the word that logicians use when you take a symbol and you put content into it. When you take form and fill it with content. So if I say all S is P, that's symbolic. It's a symbol. We're not doing symbolic logic, but S's and P's are symbols. If I say all S is P, and S represents the subject term, P represents the predicate term, I'm giving you the form of an affirmative universal proposition. But if I say all politicians are liars, now I'm instantiating that. I'm putting content into that. It doesn't have to be about politicians. I just keep going, all elephants are mammals. So what are the two classes? Elephants is the subject, mammals is the predicate, And what is this? Quantity, it's universal. What is the quality? It's affirmative. So Aristotelian logic became very important for 2.5 millennia. It's still here, it's in our books, and it goes through a giant metamorphosis in modern times with the rise of symbolic logic. So we have these two really highly refined, and as time went by, it got even more refined. There's classical deductive reasoning, which we're studying now, the essence of which is the syllogism and immediate inferences. And then there's symbolic logic. We're just going to touch on that in this class. And then, as I told you, my colleague teaches a whole course on that. So during the Middle Ages, Aristotle was so important. He still is so important, but in the Middle Ages, he was like the main man. They didn't even have to name his name when they wrote things. They just says, as the philosopher says, and everybody knew they were talking about Aristotle. So in the Middle Ages, only the learned people could read and write in the Middle Ages. The educated, which were the aristocracy, and then the clergy. And everything written was in Latin. So they have this word affirmo, A-F-F-I-R-M-O. And they took the A from that word affirmo, which means I affirm. And then they call this all S's P, no matter what S's and P's are, it can be any class. I've been using politicians and liars, or elephants and mammals, it can be anything. All trees are plants, big plants. All humans are mortals. You can put anything in there. It can be fanciful things too. All unicorns are figments of poetic imagination. You could. So what is the subject of that term? Unicorns. What is the predicate? Figments of poetic imagination. So you have to get good at that, of seeing what is the subject and what is the predicate. Gopi has examples. Well, maybe we could go over a few of those. So back to the Middle Ages then. So in the Middle Ages, they have this word affirmo, which means I affirm. They took the A, and so this all S's P came to be called an A proposition. So that's like a symbol for all S's P. And you can put anything in there, any class of S or P. So all S's P is an A proposition. That has to become immediate knowledge, right? Fast knowledge. There's different levels of learning something. Like I'm learning from practicing music. You can know something, after you figure it out, and then there's immediate recognition. That's what we need now. Like if you want to play music, you have to bring it to that level. Or if you're doing sports, you can't be thinking about where you're going to run or what foot you put forward. It just has to become fast, immediate recognition. So I want that to be immediate recognition for you. If you hear a proposition, it means all S is P. And you have to know that the quantity is universal and the quality is affirmative, okay? Now, if I say no S is P, that's still universal because I'm talking about the whole class, only I'm excluding one class from another, one category. If I say no politician is a liar, that's probably a false statement given my experience. But it doesn't matter if it's true or false for now. It's going to matter. It does matter. But when you're looking just at the reasoning process, it doesn't matter. Validity is independent of truth. Although this, I don't mean to complicate things, but this is important to realize. One definition of validity is that if the premises are true, the conclusion has to be true. There's no way for the conclusion to be false if the premises are true. That's the very definition of validity. So sometimes you can give another definition would be the conclusion follows with absolute necessity from the premises, or the premises provide absolute, how does he say it? Conclusive grounds for the conclusion. But another definition of validity is that if the premises are true, the conclusion has to be true. See, that's the beauty of the syllogism. I also want you to see the beauty of this too. This is Intellectual things can be beautiful too, just as well as sensuous things like flowers and horizons. There's a beauty, even to the syllogism. The beauty of it is if somebody presents these premises and they're all true and they make a valid argument, then the conclusion has to be true. Lawyers use this, they know this. They'll develop a premise, they'll develop another premise, and then they'll just back away and just wait until all the jury just make the inference themselves, because there's no way for these premises to be true and the conclusion to be false. But having said that, validity is independent of truth. Okay, let's go back to these 4 kinds of propositions then. So the A proposition, that should be immediate recognition now. All S is P. So you can put anything in there. Putting something in there, that's called instantiation. Copy, like I said, he doesn't use the word very much, but it's a very important concept for you to understand, because that's when you're going to, whenever you judge somebody's argument, it's already instantiated. And if you're going to construct an argument, you have to instantiate the argument. So when you put content into form, then that's instantiation. So if I say no S is P, I'm still talking about the whole class, only I'm negating the relationship among these 2 classes. So if I say no politician is a liar, then that's universal still, just like the A proposition, only it's negative. It's not affirmative, because the word no is there. Okay? Don't confuse the word no from non and not. These are 3 different, in sometimes words that mean the same thing in some contexts mean something different in another context. So in logic, it's very important to keep these 3 words separate. They don't use many words in logic, but the words, it's like math, everything is very concise. I've even noticed who math majors, they're very careful about very small little things, like the word or and. It's a big difference if I say or and. People lose their whole livelihood sometimes just on the word or and or something. So in math and in logic, these words make big difference. So don't confuse no from non and not, okay? So if I say no S is P, and I can put anything in there if I want to instantiate, no politician is a liar, then that's called an E proposition. And that comes from the Middle Ages too, from the Latin nego, N-E-G-O. They just took the E out of that word. And then, so as soon as you see E, you know that it says no S is P. And you can put anything in there for S or P, okay? Now remember I told you there are 2 quantities and 2 qualities. So if there are 2 quantities and 2 qualities, there are going to be 4 variations of standard form categorical propositions. So there is some S is P. If I say some politicians are liars, I'm not talking about all the politicians. I'm just saying some of them are. And I'm not saying that they say a lie now and then, that they're habitual liars. That's what it means to be a liar. But now we're getting into the content. If I just say some S is P, and then you can put anything in there, you can instantiate anything. That's called an that's called an I proposition. They went back to the word affirmo, A-F-F-I-R-M-O. They took the I out, and then the I represents some S is P. So what is the quantity of that proposition? It's particular. Remember, there's only universal and particular. All or some. Or no is universal also, but it's negative. So it's particular and it's affirmative. You're not negating anything. If I say some S is P, I'm not negating anything. Some politicians are liars. Some clouds are Syria's clouds. I'm not negating anything. So I'm just saying one class is partially included in another class. So that's called an I proposition. And then there's only one more kind. It's called an O. So they went back to the word nego. which means I negate, and they took the O out, and that's some S is not P, okay? Some S is not P. Some politicians are not liars, for example, or some clouds are not cirrus clouds. Cirrus, is it? Cirrus. Sirius, that's something else. Cirrus, I think it is. So some S is not P. I'm just saying there's a part of that class which is the subject, and it's not part of this other class. Partial exclusion. So that's called some S is not P. I can put anything in there for S and P. Okay, and that's an O proposition. Now, so you got A, E, I, and O. And I'd like you to memorize it this way. I just made this little chart, so I don't have a blackboard. On the top left-hand corner over here, I have A, so that's all S is P. On the top right-hand corner, over here, that's E. It says no S is P. And then on the bottom left-hand corner, it says some S is P. And then on the bottom right-hand corner, it says some S is not P. I'd like you to memorize it in this way, this form, visually. You know, like I told you, I put a lot of thought into how people learn things and how I learn things. And I think that I can help you that way. So if you memorize it this way, it's going to help you later on, because I know what's coming up. So make this square, put an X in the square. On the top left-hand corner of the square, make an A proposition. On the top right-hand corner, make an E proposition. In the bottom left-hand corner, an I proposition. This is going to really help you for the square of opposition and later on. So just learn it this way. And then in the bottom right-hand corner, O proposition. So A says all S is P, E says no S is P, I says some S is P, and O says some S is not P. This has to be immediate recognition. Now, we can use this later to make immediate inferences, but I took this out and I'm going to put it in part 2 of our course, because now you're actually creating something. And I'm trying to make 2 parts of this course. First part is critical thinking, second part, inventive thinking. So we'll postpone that, but learn it this way. Now, if you look next to the A, E, I, and O propositions, I made little circles that overlap. Those are called Venn diagrams. So there was this man who lived in the early 19th century, Venn. He was born in 1834. He died in 1923. And he completely revolutionized the way we think about categories. He made circles. Now, these are simple ones. It's going to get a little more complicated. But since we're talking only about subject and predicate terms, then you need just 2 circles. And they need to overlap. So there's going to be 3 regions of the circle. Let's look at the A proposition. So you have a predicate term and the subject term. And then if you make the 2 circles overlap, you have 3 areas. Okay. If I say, now this is the hardest one. You have to learn how to diagram. I want you to learn how to diagram these 4 kinds of categorical propositions. This is important because this is one of those building blocks that if you don't get it, then you won't be able to determine the validity or the invalidity of arguments. So that's why this is really important. The hardest one is the A proposition, because you have to think in a negative way. It trips people up. So take your time and don't rush through this. Learn how to diagram an A proposition, okay? If I say all S is P, you have to think to yourself, there's no S that's not a P. Or think this way, if there is an S, it's going to be P. If I say all politicians are liars, what I'm really saying is that there's no politician that's not a liar. Or another way of thinking it, if this person is a politician, he or she is a liar. That's what that statement says. Like I said, it's not true. There's some good people who are politicians. only the highest degree of cynicism will, you know, make you think that way. So this is how you diagram that. You have to cross out all the S's that are not P's. So it's counterintuitive because you're crossing something out, but it's a universal affirmative proposition. So that's the hardest one. The others, it'll be a lot easier. The other three are easy compared to this. This is what trips people up. So if I say all S is P, just think this way and be real careful about the way you're thinking. If I say all S is P, that's an A proposition. It's universal, it's affirmative, okay? The quantity is universal, the quality is affirmative. If I say all S is P, I mean there's no S that's not a P. Or another way of saying is, if it is an S, it's going to be a P. Okay? But think the first way, it's going to help you to diagram. And sometimes, why not go back to this example about politics? Sometimes, like I told you, if you just remember one example, it doesn't have to be about politicians, but that's the one that jumped in my head this morning. So if I say all politicians are liars, I mean, there's no politician that's not a liar. So I have to cross out all that realm, that whole space that's a politician that's not a liar. So if there are three spaces there, I have to cross out the one, I have to cross out all the S's that are not P's. I cross that out because I say all S is P. That means if there is an S, it's going to be a P. So I have to cross out all the S's that are not P's. Okay. So don't confuse it. If you just stay close to my way of thinking here, then you won't get confused. If you start bringing in all kinds of weird stuff, you'll get confused. So think this way. All S is P means there's no S that's not a P. So let me cross out all the S's that are not P's. Just think that way and keep it simple. In fact, Copy is a little bit long-winded, and I think where I can help you the most is to make things simple and make you see what's important and what's not important. I think that's pretty much the job of the philosopher, to say what's important. All right, so that's an A proposition. Learn how to diagram that and get really good at that. E propositions are easy. No S is P. That just means there's no S is P. It's just like it says. So you got to cross out all the S's that are P's. So that's right there in the middle. You cross that all out. That diagrams that. It says there's no S is P. Some of you may have had this in math class in high school or something, but review it and make sure you get it, because we're going to add another circle to this now later on. And then you have three circles to deal with. Now, why am I making little X's there with the I and O proposition and not crossing things out? And this is important. There's a big debate in logic, but most logicians agree that only I and O propositions have existential import. Now, the word existential can mean all kinds of things in different contexts. The way logicians use existential import is literally, they mean it exists. So with I and O propositions, when you diagram them, you make an X. And when you make the X, think to yourself, there exists at least one S such that S is P, if it's an I proposition. If it's an O proposition, when you make that X, then later you don't have to say that to yourself, but at first say it. There exists at least one S such that S is not P. Okay, so only I and O propositions have existential import. There's a big debate in logic about this, but the consensus among logicians is this, that only exists. So what does that mean? That means when you assert an A or an E proposition, you're not asserting the existence of any entity. Let's go back to our example about the politician. If I say all politicians are liars, the A proposition, I'm not saying that there even are any politicians. And I'm not saying there are any liars either. I'm just saying if there is a politician, this politician is going to be a liar because all politicians are liars. But I'm not positing the existence of any entity. And the same thing with an E proposition. If I say no politician is a liar, I'm not even saying there are any. I mean, this sounds weird, I know, but it makes more sense. It has more implications later. So When I say no S is P, or no politician is a liar, I'm not saying that there are any politicians or liars. I'm just saying if there is a politician, he or she is not going to be a liar because no politician is a liar. That's what that statement, that proposition says. But if I say some politicians are liars, now I'm making an I proposition. I'm positing the existence of politicians. I'm saying there exists at least one politician such that this politician is a liar. Okay? And the way you diagram that is this way. Some S is P, you put the X right there in the center where S's and P's cross. There's only three realms. There are the S's that are not P's, there are the S's that are P's, and then there are the P's that are not S's. So there exists at least one S such that S is P. So you have to put that X right there. Now later on, when we add a third circle, it's going to get more complicated. Sometimes you have to even put it on the line because it could go one way, it could go another way. That's going to be a little more tricky, but don't worry about that now. Just remember, if you say some S is P, then you put it where the S's and P's cross, in that space, not on the line, in the space. And then the O proposition, some S is not P, some politicians are not liars, or some clouds are not cirrus clouds. You put the X, if I say some S is not P, you put the X in the S's that are non-Ps, right there. Because those are the S's there, those are the S's that are non-Ps. These are the S's that are Ps, and these are the Ps that are non-S's. So you have to put the X right there. So you have to get really good at this, be able to diagram. And here's what I would suggest you do. I'm not sure the page number because I'm using a different edition of the book, but in my book, there are exercises after this section, section 5. It's probably the same in the 15th edition, but there are exercises that ask you to identify the subject and predicate terms. And what I would do is then symbolize those, go from content into form, put it in standard form. Like instead of saying all politicians are liars, just put all S is P. So in this course, we're gonna move in two different directions, from content to form and from form to content, okay? Usually in critical thinking, you go from content to form. In fact, when we study chapter 7, at least in my book, it's probably the same. There's gonna be little methods of how to translate arguments from ordinary language or natural language into standard form. So you're going from content to form. But in the second part of this course, when we're actually constructing, inventing arguments, you're going to go from form to content. So these exercises, like no athletes who have ever accepted pay for participating in sports are amateurs. That's one of the examples from the book. So what the exercise is asking you to do is identify the subject and identify the predicate. And then what I would do, just to get some exercise with this, diagram it. Put it in. So first of all, no athletes who have ever accepted pay for participating in sports are amateurs. So the question is, what is the subject term of that proposition? Well, athletes who have ever accepted pay for participating in sports. That's the subject, all that. So that's important to realize. This class doesn't have to be just one word. It's one class, but it could be, sometimes has to be spelled out. Like in this case, the subject term is athletes who have ever accepted pay for participating in sports. Okay, that's the subject. And then what is the predicate? Amateurs. Okay. So no athletes who have ever accepted pay for participating in sports are amateurs. So that turns into no S is P. Now, in propositions, there's all kinds of verbs. When you learn a language, you learn all these verbs, right? In logic, all the verbs are just turned into is. That's called a copula. Okay, so it can be past tense, future tense, it can be any verb, run. Every verb presupposes the verb to be. That's why when you study a language, it's very important to know how to conjugate that verb, or to know about that verb about to be, because every verb presupposes to be. Okay, so what they do is just reduce all verbs to is. So you lose a lot when you go from ordinary language to standard form. You lose all the nuance of language. But what you gain is the precision of the logical structure of that language. And so you lose that on purpose in order to get that kind of logical rigor. But when you're actually speaking, you use all the nuance you can. The more developed you are linguistically, the better speaker you are. You become eloquent finally if you practice and learn. So when you go from content to form, you lose a lot of meaning. So if I say no athletes who have ever accepted pay for participating in sports are amateurs, it turns into no S is P. And you know that S means amateurs that have accepted pay for participating in sports. And then the P is amateur. Athletes, I meant. The A is, the subject is athletes who got paid for their sports. And then the predicate term is amateur. So it turns into no S is P. That's an E proposition, right? It's universal and it's negative. Okay. And then diagram it. You can go beyond that just to practice. Diagram. And it's going to look like all old propositions. You always cross out where the S's and P's. So you have two circles, S on one side, P on the other side. If I say no S is P, you cross out all the S's that are P's. And what does that say? If it's an athlete, it's not going to be somebody who got paid. That's the very meaning of the word amateur. Let's do one more. No dogs that are without pedigrees are candidates for blue ribbons in official dog sports sponsored by the AKC, American Kennel Club. That's a true statement, by the way. I happen to know. You can't, if you're going to be in a conformation show, you have to have registered pedigree. Okay. So what is the subject term and what is the predicate term? Well, the subject is dogs that are without pedigrees. That's the subject. And then the predicate term is candidates for blue ribbons in official dog shows sponsored by the AKC. All that. Now that you got to know there's if you read that whole sentence, the word are, which is a form of the verb to be, is used twice. So you got to think and use your common sense to see which one is the copula and which one is just part of that class. Like, let's go back. No dogs that are without pedigrees are candidates for blue ribbons in official dog shows for the AKC. The first time the word are is used, that's not a copula. That's just part of that category. Dogs that are without pedigrees. Are, now that's the copula. Candidates for blue ribbon and all that is the predicate term. So you got to, you can't do things mechanically and by rote. You have to think. Maybe we should do one more because we just did two. And then I would go ahead and diagram that. Make your two circles, cross out the S's and P's in the middle. Let's do another one. There's one that says this: some paintings produced by artists who are universally recognized as masters are not works of genuine merit, that either are or deserve to be preserved in museums and made available to the public. That's a long one. And so don't worry about the truth or falsity of these now. Just try to follow the directions. So what are you supposed to do? You're supposed to find the subject term, the predicate term, and then determine if it's an A, E, I, or an O proposition, and then diagram it. They're not asking you to do all that, but if you do all that, then you're going to do everything that I've been talking about. So let's go over it again. Some paintings produced by artists who are universally recognized as masters. Okay, all that. The word some is not part of the predicate. All, if I say all S is P, all is not part of the subject term. And is not either. That's the copula. It's just S's and P's. So if I say some paintings, the word some is not part of the subject term. That's just a quantifier. Some paintings produced by artists who are universally recognized as masters. All that. Paintings produced by artists who are universally recognized as masters. All that is the subject term. But notice the word are is part of that, but that's not the copula. So this is going to maybe trip you up. And Kopi didn't explain that, so I'm explaining that to you so you don't get confused. Because sometimes you can see there's a verb there. In this case, it's even a form of the verb to be, are. And it's not the copula. The first are is not the copula. Some paintings produced by artists who are universally recognized as masters, that's all part of the subject term. The word are is still part of the subject term. Then the next are not. Are is the copula, not is the qualifier. And then after that, that's the predicate term. Works of genuine merit that either are or deserve to be preserved in museums and made available to the public. All that is the predicate term. Notice the word are is used in that too, but that's not the copula. So that's an O proposition. Some S is not P. And then how would you diagram that? You just put an X in the realm where there's S's and no P's. So what I'd like you to do is be able to identify the subject and term and predicate terms of propositions and separate out the quantifiers and qualifiers from that, and then reduce it to an either A, E, I, and O proposition, or O proposition, and then be able to diagram those four and set it up. Always think in terms of this square, because that, and then later on you can forget about the square. But I've learned about learning as time went by, and the way you learn something is really important because that's going to be how you conceptualize it. And then later on you can drop that form and it'll just be there. Then you can start moving it this way and that way and doing all kinds of creative things with it. But at first, it's nice to keep everything in one form, okay? So that's the gist of it. Yeah, there's quantifiers, qualifiers, subject and predicate term. There's four kinds of propositions, A, E, and I, and O. Always put the A in the top left-hand corner, put the E in the top right-hand corner, put the I in the top left-hand, or the bottom left-hand corner, and the O. And remember, only I and O propositions have existential import, and learn how to diagram all those four. The A is the hardest one. All S is P means there's no S that's not a P. So you have to cross out the S's that are non-Ps. So now there's one more concept and that I want to talk about, and then that'll be enough for this. It's called distribution. This may not look like it's important now, but later on, when we learn how to test for the validity of arguments, there are three methods of making the test. I'm going to ask you to learn all three methods because all three teach you something. The best way is the Venn diagram technique. Then there's another technique called the rules method. You just have to memorize these 6 rules. They're not easy though. 3 of them are a little bit hard, but there's 6. You just memorize these 6 rules. If the argument breaks any of the rules, it's invalid. If it doesn't break a rule, it's valid. And then there's another way. It doesn't teach you very much, but it's a quick way. There are these 15 names that these monks in the Middle Ages came up with, and they are mnemonic devices for the 15 valid syllogisms. So I'm going to ask you to do all 3. You know, none of my teachers, when I studied logic, and I was a grad assistant at Penn State, they didn't go as deep as I'm going, as carefully as I'm going into the syllogism. So I decided to make a course where I will have my students master the syllogism. So I'm going to ask you to do all 3. Usually they just use the Venn diagram, or some people do the rules. And I'm asking you to do the third one is going it's called the coined named method. That's going to be very helpful in constructing arguments. That's why I'm going to have you memorize these 15 names. Now, so you need to know about distribution in order to learn how to do the rules method, because part of the three of the rules are going to be whether or not there's this syllogism that we're going to test breaks any of these rules regarding distribution. So if you don't know what distribution is all about, then you won't know if it broke a rule of distribution. And I found a very simple way of memorizing. You can read what Copy says, and he explains about distribution. But it sort of racks your brain. I do want you to read it, though. Go ahead and read it. It's a little bit long-winded, but he explains why it's the way it is. But sometimes I found when I'm learning something, it's always good to know why. I mean, as a philosopher, that's why I became a philosopher, because I want to know why. But sometimes if you're learning something, you can get overwhelmed with explanations about things. And then, so sometimes it's good just to simplify things and not know why. And so just memorize this for now. And then, but it's not that hard to know why either. You can read what Copy says. Do both, actually, but memorize this. So I made a little diagram of distribution. And that square, so there's A, E, I, and O propositions. And what you have to realize is that distribution means whether or not all or part of a category is included or excluded in another category, subject and predicate categories or classes. And in an A proposition, only the subject term is distributed completely. Distributed means the whole class belongs to another class. So if I say all S is P, let's go back to the politician example. All politicians are liars. Again, it's probably not a true statement. But if I say that, it's an A proposition. I'm talking about all politicians. But I'm not talking about all liars. There can be liars who are not politicians too. So only the subject term is distributed in an A proposition. So I put a little square around the S. I just put A, E, I, and O, and subject and predicate for S and P's for all four. And I made the square again. And again, I put the A, E, I, and O in the same place because I want to memorize it that way. Okay? And so you just have to remember that an A proposition, only the subject term is distributed. And so I put a little square around that. So memorize it that way. In an E proposition, both the subject and predicate terms are distributed. If I say no politician is a liar, I'm talking about the whole class that are not politicians and the whole class of liars. So both the subject and predicate terms are distributed. So I put a little square around the S's and P's in an E proposition. If I go down to the I proposition, some politicians are liars. I'm not talking about all politicians, and I'm not talking about all liars. So neither the subject nor the predicate term is distributed. So I didn't put a square around the S or P there. And then if I say no S is P, or some S is not P, with the O proposition, only the predicate term is distributed. So it's just the opposite of an A proposition. And the E is the opposite, the inverse. So with A propositions, only the subject is distributed. With O propositions, only the predicate. So just memorize that, visually. Just make a square, A, E, I, and O, put S's and P's, and then make a square around the S of the A, make a square around both the S and E of the E, make a square around neither one for the I, and then with the O, just put a square around the P. If you memorize that pattern, then you can reproduce that in your mind as a mnemonic device, and you'll be able to know with an A proposition which is the subject or the predicate term, or neither one or both, if they're distributed. But you have to know this. If you don't know this, you won't be able to know if a syllogism breaks any of the rules of distribution, because you won't know what distribution means. So I made a little mnemonic device for that. But read what Copy, he explains about distribution. And that's basically everything in that whole chapter. And he goes over it, um, the other thing in that chapter is called the traditional square of opposition and conversion, obversion, and contraposition. And like I said, I'm going to bracket that. This is the first time I did that, but I realized when I was teaching before that really what you're doing when you're doing those square of opposition and conversion, obversion, and contraposition is actually generating a new argument. So that's really not part of critical thinking, properly speaking. I feel I'm trying to fine tune my own original insight here. The original part of this course that I feel proud of is taking these principles and methods used to distinguish correct from incorrect reasoning. That's critical thinking. Transforming them into tools to actually construct arguments. I feel good about that. I mean, as a philosopher, what we try to do is come up with our own ideas. Otherwise, we just say what other people say, and parrots can do that. So I came up with something, and I'm trying to fine tune it. So in fine tuning it, I realized that the square of opposition and those other immediate inferences, you're actually generating arguments. That really belongs to inventive thinking more than. So I'm going to wait on that. But if you memorize the material the way I showed you with that square, then it's going to fall in place very easily. So I'm setting things up for you to learn later on, it'll be in place. Okay? All right, so if you listen to this and you do the readings of chapter 5 and just eliminate now, or for now, put on and just bracket the square of opposition and the further immediate inferences, and you should be all right. Okay. All right. Thank you. I'll be waiting. Tomorrow I'm going to check for your informal fallacies. Just send those in Dropbox in any way that I can open them. All right. I'll let you know if I can't get things open. All right.